Okay, we're going to continue into section 12.1, into the second section, which will be a little shorter. I think the work will be a little easier. So this is going to be section 12.1, continuing. And what we're going to be asked to do is determine if a function is one-to-one. This is read as 1 to 1. Okay. So what this means is, first off, just to kind of remind you, because we may have not talked about this for a long time, and I don't even know if we discussed this in this class, because the idea of what makes a relation a function is something that is taught in Math 90. So the graph of anything, a graph is used to represent some type of relationship. So any graph of anything mathematically related, we can call it a relation. So if we want to determine is a relation a function, you may have recalled learning about something which is called a vertical line test. And the way a vertical line test works essentially is, let's say you're just going to draw a couple different windows of, we'll draw kind of graphs in these here. The way a vertical line test works is as follows. I may have something like a straight line here. I could have another straight line going this way. I could have a line that looks like this, or I could have something that looks like this. So I should be able to draw, if a relationship is a function, I should be able to draw vertical lines through. If each vertical line crosses once, then this is a function. So this is a function, this is a function, this is a function. Let me see if I could do this here. I'm going to just change this up a little bit. It looks hokey, but this one here, this is not a function. So because if I draw a vertical line, it crosses the graph 2 times. If I can do that anywhere on the graph, even once and only once, then the relationship is not a function. Okay, so that is the first part of the question. The next thing you're going to be asked is the function one-to-one. Now, to determine if a function is one-to-one, we have what's called a horizontal line test. And what we mean by function one-to-one is that for every value of y, we have only one value of x. So what we're going to do now is we're going to go ahead and we're going to draw horizontal lines to run this test. So it looks like no matter where I draw a horizontal line, it's only going to cross the graph once here. So we can say that this graph is one-to-one. We can say this function is one-to-one. However, take a look at this here. So let's say that this point maybe has a value of -2, 3. This point maybe has a value of 4, 3. Same value of y, 2 different values of x. Because this line crosses the graph more than once, this is not one-to-one. So if you want to know if the graph of a function, and you're going to be given that it is a function, if you want to know if it's going to be one-to-one, that will depend on the vertical line test. So to kind of walk you through this, we're going to go ahead and kind of plop the textbook up here for a moment and take you through an example of 4 lines. So I'm going to just kind of strategically put this here because the textbook examples are pretty clear. And one thing you can do is you can just take kind of a piece of paper and drag along. Let's just take a look at 45. If you see the graph show up more than once on the edge of that paper, probably is not one-to-one. It looks like it's going to be okay. Let's take a look at 46 though. go down on that, and you see right there, it looks like if we draw a horizontal line, we're going to cross the graph of that function 3 times. So whereas that may be a function, it's not going to be one-to-one. Same phenomena going on with 47. This line here, a horizontal line, will be crossing once. Oh, but when we get here, we can put one horizontal line through at 3 different points. So that's not going to be one-to-one. Looking at 48 here, and we only need to be able to do that with one line. If we put one line through a function more than once, it's not going to be a function, or it's not going to be one-to-one. So it looks like graphs 46 and 47 are not one-to-one. In fact, if you see the solution of the book, you'll see yes, that's the case. But if you look at 45 and 48, you'll see that those are one-to-one because a horizontal line will pass through the function only once. So that's how we determine if a function is one-to-one. For the remainder of this section, we're going to take a look at functions that are one-to-one and find what is called an inverse. Now, we're not going to focus on the graphing of inverse functions. You are going to take a much deeper look at that once you get into section 102. But you should be able to know how to identify what inverse functions are. And before we are done here, I will show you what they're going to look like on my graphing calculator, which I'm going to show you here. So let's go ahead and take a look at the following questions. So for these questions, we're going to actually, we're not going to determine if it's one-to-one. I'm going to give you ones that are one-to-one. For a one-to-one function, we're going to find the inverse function. And I think you'll understand what an inverse function is a little more as we see the graph of these. So this is going to be the set of directions we're going to look at each of these questions with. So let's just go ahead and start with question 15. And we're going to take a look at f of x is equal to x plus 2. Now, because the graph of x plus 2 is a straight line, it is a function. It would pass the vertical line test. It would be one-to-one because it would pass the horizontal line test. So how we find the inverse function works as follows. Please feel free to stop the video to kind of take down the steps. Step 1, replace replace f of x with the value of y. So we're going to reintroduce y back into this because it's going to simplify, which is going to be the next step. So step 1, replace f of x with y. Step 2 now is we're going to change the place of x and y. So we are going to take the y and the x and we are going to switch them out wherever they appear. So this is step 1 here, where I replace y with f of x. Here is step 2, where I take the x and the y and I switch them. And now I'm going to go ahead and solve this for y again. Now, so step 3 is going to be the body of work I'm going to do here to get y by itself. So the first thing I'm going to do is I just like y being on the left. That's just me, and I think most students are comfortable with that. So I'm going to go ahead and I'm going to take this y plus 2, I'm going to move it to the left. I'm going to take the value of x and move it to the right. I'm not subtracting, I'm not adding, I'm just kind of flipping it. So I'm going to, if you picture like this kind of a feng shui or whatever they call that, the yin yang, I'm going to take y plus 2 and I'm going to rewrite it the other way. So I'm just moving what's on the right to the left and what's on the left to the right. Just my preference. After that, I'll go ahead and I'll subtract 2 from both sides. And then I'm going to have y is equal to x minus 2. Okay? So that is the first. So after we're done with this, so step 4 now is we're going to take a look at what's called inverse function notation. So if we have f of x is equal to x plus 2, and this, what we figure out here is the inverse function, we're not going to replace this with f of x. We're going to replace this with what we call f of negative 1 of x. or f inverse of x. So up here, this is read as f inverse of x, okay? And that's going to be equal to x minus 2. So this is the inverse function that we're looking for in the problem. So I'm going to work through probably about 4 of these questions before we go on and take a look at what the graph of these look like so you can kind of see the connection of what's going on. So that's 50. Let's go ahead and take a look at 56. So that's 50, 56. The original function x is equal to 1/3 x plus 2. Hopefully most of you recognize that that's a straight line. So step 1, we're going to replace y with, we're going to replace f of x with y. Step 2, I'm going to switch the y and the x out. So this is going to be x is equal to 1/3 y plus 2. So this is step 1. Step 2 is I switch the x and the y. 3, I'm now going to solve this for y again. So I'm going to do some body of work here to get the y by itself. So again, I just want to bring the y over. So I'm going to just kind of switch these around. You don't have to. That's just my preference. So 1/3 y plus 2 is equal to x. The one thing I don't like is I don't like this 1/3 next to the y. So I'm going to go ahead and multiply the entire thing through by 3. So if you want to write this, I'll write this as a separate step myself. So I'm going to go ahead and put the 3 over here. 3 times the third will give me y. 3 times 2 will be 6. And then that's going to be equal to 3x. Now I have y plus 6 is equal to 3x. I'm going to subtract 6. So y will give me 3x minus 6. And because I'm finding the inverse function, I don't put the f of x back. I put f of inverse. F inverse of x back. So this is the equation I'm looking for. So if f of x is equal to 1/3 x plus 2, the inverse of x is 3x minus 6. So let's go ahead and take a look at 2 more problems. Next one is 62. So we have f of x equals 3 over x. Okay, so we're going to follow the same steps again. We want to find the inverse function. Y equals 3 of x. Remember, replace f of x with y. I'm going to switch this out now, so I get x is equal to 3 over y. Now, in this one here, because of the step I'm going to use to kind of simplify this, I don't have to worry about switching these around. So first, I replace f of x with y. Second, I switch the x and the y out. So what I'm going to do in this one is that you can do this one of 2 ways. You can multiply both sides by y. But we'll just go ahead and do that because I think that's what the step is the class is most familiar with. This is going to be yx is equal to 3. And now, if once I do that, if I divide both sides by here, why don't I like the way this is turning out? So if I divide both sides by x, get y equals 3 over x. So I think we might have a situation here where this does not have an inverse. So let's go ahead and put this in. Okay. Yeah, and what I figured out is that this does have an inverse. The inverse actually happens to be itself. Okay. This is probably not the best example to look at for this, but let's keep going forward. I'll make sure the problems that I assign you do in fact have an inverse. Let's take a look at 66 is probably a better one. Guys, I'm going to ask you to kind of just nix that question. So let's look at 66 first and then 68, because you need to see ones like 66. F of x is equal to 3x plus 2 over 5. Okay, again, first step, replace f of x with y. And then I'm going to switch x and y now, so make that x equals 3y plus 2 over 5. Yeah, I'm going to go ahead and, well, let's see. There are a couple ways you could do this, but let's go ahead and just kind of switch everything out. So I'm going to move this now. 3y plus 2 over 5 equals x. The next thing I'm going to do is get y by itself, is I'm going to divide or multiply both sides by 5. So I get 3y plus 2 is equal to 5x. Next, I'll subtract 2 from both sides. So we get 3y is equal to 5x minus 2. I'm going to divide everything by 3. So now I get y is equal to 5x minus 2 over 3. And then finally, my last step is to replace this with f inverse of x equals 5x minus 2 over 3. So if the original function is 3x plus 2 over 5, the inverse function is 5x minus 2 over 3. So let's begin to take a look at what some of these look like graphically now. So we're going to skip away, and we're going to come back to 68 in a little bit here, but we're going to go ahead and take a look at what these look like graphically now. So, okay, clear that out. I don't know if the light helps, or actually the light definitely helps. So I'm going to try to bring as much light to this as possible without causing too much glare. So we're going to take the original function here from problem 50 of x plus 2. And we're going to take the second problem is going to be x minus 2. I'm going to type in the next two set of equations here for y3 and y4. The original problem here is going to be so I'm putting all these in at the same time, and I'm going to only graph a couple at a time. Plus 2. Let's see, it's going to be 3x minus 6. The next problem, we have our function here of 3x plus 2 parenthesis divided by 5. Y6 is going to be 5x minus 2 divided by 3. And a last line I'm going to put, you're not going to understand why this is going to be the case till a little later perhaps, but I'm going to have you analyze this. We're just type in y equals x. So what I'm going to do is turn the graph of these off. And we're going to graph each of these a little differently. So the first graph is going to graph like a regular line. The second graph is going to graph what I call the turtle. And I'm going to go ahead and I'm going to make this line here really thick. Okay, so we're going to first start off by graphing y1, y2, and then y7. So these are the first pair of, these are in the functions that are inverses of each other, and graph with the line y equals x. And let's go ahead and see what happens with this. So I'm going to press the graph button now. Okay, so you see that the inverse line is in the middle here. Let's go back to y. I'm going to go ahead and turn this off now. So the first two lines that we saw graphed are not going to graph. The next two lines are going to graph. See, that's the turtle coming across. Here comes the value of y equals x. And that's the second pair of graphs of these. I'm going to go ahead and turn these off now. Now I'm going to see the graph of these two functions and see what these look like. Here's the turtle crawling along. And finally, here's the graph of y equals x. So what we're going to do next, and this is a real nice one actually to go ahead and compare, we're going to look at, actually probably the first two is going to be a nice one. So we're going to go ahead and look at the table. Let's see. So I think what we'll do is we'll go back because we'll look at y1 and y2 for this. This ought to illustrate this more nicely. Okay. So if you take a look here, if you want to know the points on y1, a point on y1 would be 1, 3, 2, 4, 3, 5. Okay, but then take a look at y2. So if you have like 1, 3, 2, 4, 3, 5. So let's go ahead and write that down. So if you're looking for the points on this, some points on f of x are 1, 3, 2, 4, 3, 5. Some points on f inverse of x are going to be 3, 1, 4, 2, 5, 3. And if you notice what happens here between the function and the inverse function is that the x and the y switches, which makes sense because what do we do in step 2? We switch the x and the y. And what you'll find is that the graph of y equals x is what we call the line of reflection. And this is where the points of x and y switch. So this is going to be something of a precursor of the kind of work you're going to be doing when you're in Math 102, where you're going to see those functions reflect across that axis. So you're going to study this in greater detail, but I thought I'd give you a preview of that here. One more question before we finish off section 12.1, and that's going to be question number 68. So the function for this one here is x to the third, or let's write this in proper function notation here. F of x is equal to x to the third plus 7. So again, step 1, I'm going to replace f of x with y. When I do that, I'm going to go ahead and I'm going to switch out x equals y to the third plus 7. So when I do this one here, I'm going to go ahead and I'm going to subtract 7 from both sides. That'll give me x minus 7 equals y to the third. Notice I didn't switch them out this time. So, if you want to, you're welcome to do that. But now I want to get y, so I'm going to take the cube root of both sides. And make sure you indicate that you're taking a cube root. If you have that, if that's not there, you'll be marked points. So y is going to be equal to the cube root of x minus 7. And since y is equal to this, I can say f inverse of x is equal to the cube root of x minus 7. And that is our inverse function. So this is how we go about finding inverse functions, given that a function is 1 to 1. And we're going to go next into working with exponential functions, and then touching on the very beginnings of logarithmic functions, getting you ready for Math 102.